talking imaginary numbers now. So I know it's kind of a blast from the past. Foster's home of imaginary friends. Classic. I love it. Let's get rolling talking about some imaginary things besides imaginary friends and whatnot. Let's take a look at what is an imaginary number, So what's going on here? Well, let's take a look at some things we know here. Square root of 36, got it. No problem. That is just 6. 6 times 6 is 36, so we're okay on that. That's good to go. So those are real numbers. What happens is, in the past you type this in your calculator, the square root of negative 25 doesn't exist. It says non-real answer. It's true, these are not real answers, but we have imaginary answers. So these are called imaginary numbers. What number times itself is negative 25? Well, we know it's not 5 times 5 because that's positive. It's not negative 5 times negative 5 because that would be a positive 25. So what do we say? It's actually 5i times 5i. So the square root of negative 25 is 5i. So these are imaginary numbers. They're not real numbers, but sometimes they're useful to find these things. So they're called imaginary numbers. They were actually, the Greeks knew about these, and they actually made fun of the first couple of mathematicians. Like, hey, look at your imaginary numbers. So it actually started as a joke, finally caught on, and so it really stuck as I. So we're going to use 5i to represent the square root of negative numbers. Fantastic. Try negative 50. So what's the square root of negative 50? Well, this is a little challenging. There isn't a number that goes into negative 50. So really, what does this break down into? This breaks down into I square root 50. So if I times this by itself, the I times the I, that's really what's getting us here. If I look back at this one, 5 times 5 is 25. What is I times I? Well, I times I is I squared. And in this case, we want that to be negative 5. So really, here's the magic of it all. I squared is negative 1. That's what gives us this whole idea of 25 times negative 1 is that negative 25. So if I'm going to skip ahead to my chart here, I squared is negative 1. That's really the key to imaginary numbers. This one right here, this I squared. Awesome. Very nice. So this is great. Can I reduce that? Sure. We're pretty good at reducing these radicals. We've been practicing here for a little bit. So what does 50 break down into? It breaks down into 25 times 2. And why did I pick 25? Because what's the square root of 25? It is 5. So really, this turns into I5 radical 2. We don't write it like that. We always put the number first. So this is actually 5i radical 2. So we're going to spend some time simplifying these things. The square root of negative 50 is actually 5i radical 2. Awesome. Very good. So we're going to practice a bunch of those. Let's go ahead and fill in this table, though, if we're talking about imaginary numbers here. I is just I. So I squared is the key. This is where the magic happens. I squared, as we showed up here, is negative 1. That's what gives us this ability to take the square root of negative numbers. So what's I cubed? I mean, I cubed is really I squared times I. So what happens here? If I squared is negative 1, I is I. What is I cubed? It's actually negative I. Cool. So what is I to the fourth? Well, a couple of different ways of looking at this. You can look at it is, the way I like to think about it is I squared times I squared is I to the fourth. And if you have I squared times I squared, that's negative 1 times negative 1. You're back at positive 1. So this is the key. This is kind of like the key to imaginary numbers. If I look at I to the fifth, essentially I to the fifth is really I to the fourth times I. That gives you I to the fifth. Remember, you add those exponents, it's like to the first. So when I say that, I'm saying 1 times I. I'm back at I. So it's really just a pattern. So what is 6? 6 is actually back to 2. So it's really this cyclic pattern here where it keeps going in groups of 4. Excellent. So if you want to continue the pattern to 15, you could. You go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This would be 15 right here. What's another way to do that? Well, the way I like to think about it is 15. How many times does 4 go into 15? That's how I think about it. 15 goes into 4, what, 3 times? Gives you 12. And the key to this, what's the remainder? It's a remainder of 3. So if you look at that remainder, that gives you the same power. It's I cubed. This is the same thing as saying I cubed because it goes in there 4 times, remainder 3, which really equals negative I. So we're actually going to look at these, break these down. What about I-34 then? I-34 is, how many times does 4 go into 34? Should go in there, what, 8 times? But we're really only concerned that cycle happens 8 times. What's the remainder? It's a remainder of 2. So if it's a remainder of 2, that's like saying I squared, which we know is as negative 1. So we're going to reduce these things down. If you get a remainder of 0, it's like saying 4. It goes in there evenly, so it would be I to the fourth. Awesome, very cool. So that's the basic foundations to I. When I think about imaginary numbers, I like to think about, we did the imaginary, Foster's imaginary friends there. Here are a couple of imaginary things I like to think of, imaginary characters. Let's take a look at these. These are my top 3 favorite imaginary things out there. All right, number 1, the Abominable Snowman. Check it out. I love that. That's pretty awesome. What's my second favorite imaginary character?
Top of the morning to you, laddie.
Pelican. I like that one. And what wraps it up, the third imaginary creature. These are fake. They don't exist, I don't think. The last one, it's not Sasquatch, it's Sully Squatch. I love it. So which of these is my favorite? Gotta be the Abominable Snowman. He's definitely the most imaginary. Haven't seen a video, Mr. Bean, Algebra 2, haven't seen a video from this guy. I'm starting to wonder if this guy exists. He may be purely imaginary algebra teacher.
Next part, we're going to start solving equations, okay, with some negative values, and we got to understand how to break them down, how to get our answers, and so on. So what I want to do is I want to solve. The first step is I want to isolate for the squared term. So n squared is the squared term, x squared is the squared term, y squared is the squared term. How do I isolate? I have to get rid of the thing that's there. So this is negative 2 times, so I got to divide. So I get negative 9 is equal to n squared. Okay, how do I get rid of a squared? I square root it. So now I have n equals, now here's what you guys need to understand. When I'm solving an equation that has a squared in it, I'm going to get 2 answers. Okay, 2 answers. How do I get 2 answers? Because if I square a negative or square a positive, I can get the answer, right? Negative times negative is positive, positive times positive is positive. So that's why I always get 2 answers. So when I do this, I'm going to get plus or minus 2 answers. Plus, one's positive, one's negative. The square root of negative 9. But what is the square root of negative 9? Well, let's pretend real quick that it's really positive 9. What's the square root of positive 9? Well, that's 3. So I get plus or minus 3. But it wasn't positive 9, it was negative 9, or negative 1 times 9. What's the square root of negative 1? That's I. Anytime you see a square root of a negative in there, it's always going to be coming out as a letter I, the imaginary number I. So there is our answer for for the first one there. Okay, second one. How do I get rid of the 1? Got to minus it. I get x squared equals, do this, that's negative 7. Square root, x equals, because it's a squared in the original, I have a plus and a minus, negative 7 square rooted. Does 7 have a perfect square? No. Can I break it down to stuff come out? No. So I have to leave it there. But what did I forget? There's a negative there, so that means my answer is x equals plus or minus I square root of 7. The negative pops out as an I. Just like here, it popped out as a letter I. Okay, so there we go there. I want you to pause the video and try the third one there.
It's me, Leonardo DiCaprio. I died in Titanic. Pause the video.
Third one, I got to add the 2 over. So we'll say this is 0 here. We'll add the 2 over. Sorry, I thought it should have been there as a 0. I'm sorry. So we'll add the 2, so we get 3y squared equals 2. Okay, divide by 3, divide by 3. Y squared equals 2/3. Square root, square root. So I get y equals plus or minus. Remember, we square root is squared, we get plus or minus the square root of 2 over 3. Now, hopefully, we don't use an I because there's no negative on the inside. It's okay to have that. So plus or minus is 2/3. All right, 2/3. No I's because there's no negatives on the inside. So we're good to go there. Let's go on down. Okay, complex numbers. So the complex numbers involve an I, which is imaginary, right? Imaginary. We can't see it with our eyes. Imaginary. But so they involve an imaginary number and a real number. Real means it exists. What? They do exist. Yeah, they do. So a real number. So this is what I'm talking about. Here is the real number. This is just going to be a number. This could be -5, 1, positive 1,000, stuff like that. This could be, again, a decimal. That's okay. It's a real number. It means that you can graph it on the number line. This specific number can be graphed on a number line. BI, this is the imaginary part because it has the letter I in it. So this is the imaginary part. I cannot graph that on a number line. I can graph that on a complex number plane, but not on an actual number line. Okay, so we're going to be dealing with a plus bi. This is the way that they are written, a plus bi. So for instance, if I have something that looks like this, 8 plus 7i, and I write it as 7i plus 8, that's wrong. It has to be written with the i's at the end with the regular number at the beginning. Okay, you got to pay attention to that. We're going to do some practice problems right now. I want to add and subtract. So real quick, what I do is I have my complex number here, my complex number here, and I'm adding them together. So how do I do this? Well, I look at the number in front of the parentheses. What number is that? Oh, it's a 1. Distribute, distribute. 4 minus 3i. Plus what? Plus 1. Distribute, distribute. Plus 7 plus 9i. Now, looking at things like normal, if we had an x and x squared and stuff like that, I would combine like terms. So what can be combined? The 4 and the 7 makes 11. Negative 3i, positive 9i makes a plus 6i. Negative 3 plus 9 is 6i. That's it. That's it. That's it. That's all it is, man. It's not anything crazy. I'm sorry about that. I don't know what that is from. Oh, I hit the wrong button on my thing. Okay, this one here. I take a 1, distribute, distribute. 5 minus 2i. This is a negative 1. Distribute, distribute gives me a negative 3 minus 7i. Cannot forget the negative distributes. If you forget that, it's wrong. No doubt about it. Combine terms. 5 minus 3, 2. Negative 2 minus 7, negative 9i. Boom, right there. Try the last one. Pause video now.
I'm Chuck Norris. I can build a snowman out of rain. Pause the video.
4 plus 5 minus 12i. 4i there. So 1, distribute, distribute. I get 4i plus 5 minus 12i. Combine, combine. That makes a negative 8i plus 5. Boom. There's our answer. No, it's not. 5 minus 8i. Okay, because I have to write it this way here. I cannot put the number at the end. The imaginary number has to go there. I know it sounds great and very easy, but please don't forget that. Multiply. So multiply means two things. One is we got to multiply them. So here in the first one, we're going to distribute. That gives me what? 12. And then what? Plus 20i. Oh man, that was pretty easy. Man, that was it. Next one, distribute. Gives me 6i plus what? Plus 14i squared. But if you remember that I squared is equal to negative 1, so that I squared is negative 1, all it does is change the number in front to its opposite number. So it's 6i minus 14. But is that the correct way we write it? No, it's negative 14 plus 6i. That's it. That's your answer right there. The last one. You notice I have a binomial complex number and a binomial complex number. How do I do that? I need to make a box. Hopefully remember making these in algebra and some maybe last section. We kind of did it a little bit as well. Things like that. We need to make sure we know how to multiply binomials. So 3 minus 2i. So 3 goes here, negative 2i. 3 goes here, 7i. I just multiply by the numbers right there. So 3 times 3 is 9. 3 times negative 2i is negative 6i. 7i times 3 is 21i. 7i times negative 2i is negative 14i squared. But what do we know about I squareds? What happens to that box? It actually turns into a positive 14. I flip the number when I have an I squared. Flip coefficient. That's what we call the number in front. Coefficient. I can't spell it. There we go. All right, coefficient. So that's 14. Well, isn't this 14? And this 9 can be added together, so that's 23. And then 21i, 6i, or negative 6i, sorry, makes a 15i. So that is our answer. 23 plus 15i. That's a kind of a janky I, I'm sorry. That's a terrible I, I'm sorry. But it is what it is. Okay, so there's your answer. There's a couple try-it problems. I want you guys to try them real quick. Pause the video and then hit play. First one, 2 minus 5i plus 7 minus I. So again, we have a distributive property technically. We got to make sure we understand that. So I get 2 minus 5i plus 7 minus I. 2 plus 7 is 9. Negative 5 minus 1 is negative 6i. There is your answer right there. 1 distributed, 3 plus 7i. Negative 1 distributed, minus 5 plus 2i. Combine the 3 and negative 5 to make negative 2. 7 plus 2 is 9 i's. Yeah. Distribute the 4i here. Boom, boom. 4i and 3 makes a 12i. There we go. 4i and 6i makes a negative 24i squared. But what does the I squared do? It turns the negative 24 into a positive. It flips the sign. Doesn't matter if it's positive, it goes to negative. If it's negative, it goes to positive. It flips all the signs. 24 plus 12i, you got to write it that way. Again, it will be wrong if you do not. Last one here, I have a binomial. When I do this, you got to make sure, you got to remember it's a box. You got to box it up. Box it up. So 5 minus 3i, sorry. And then 4 plus I was getting excited singing a song there. So 4 and 5 make 20. 4 and negative 3i makes a negative 12i. 5 and I make 5i. I and negative 3i makes a negative 3i squared. But what happens to this whole box? It turns into a positive 3. Then this positive 3 in that 20, boom, 23. 5i minus 12i, negative 7i. Boom, there's your answer. All right, that is it for this video. You're done. All right, you got some practice problems, you got some applications, you got some algebra stuff and SAT stuff as well. You got questions, ask, but you should be good to go. All right, take notes, do work, be successful.